All right, so we're looking at simultaneous equations, and we want to look at specifically the elimination method. Now, the issue that we have with simultaneous equations is that we have two unknown values. In these two equations here, which I label equation 1 and equation 2, this is always a pair of equations, and you should always label them. We have two unknown values. We have unknown for P, unknown for Q, right? So that means that it provides a issue. The issue is that we cannot solve it in a traditional manner, meaning that if, for example, I had 4p plus, if it was 4p plus 3 is equal to 5, then we would simply, let's leave this as minus 5. We'd simply carry this 3 over the equal sign. It becomes negative 3. I could add these two together, and then I could solve for what p is. And I get p to be negative 2. This is the traditional sense. Traditional linear equation. Right? With one unknown value. But with the pair of equations, I have two unknowns. I am now seeing a q and a p. That means that I cannot solve it by itself, by one equation alone. We have to work this out in pairs. One of the methods for doing this is called elimination method. And to eliminate, the first thing we need to be able to identify are a pair of terms that are exactly the same. I drew a box around it. So we have 3q and 3q, exactly the same. Now, to eliminate this 3q, we have two options. We could either subtract or we could add. Now, if I was to add, let's see. If I add these two equations together, so I say 4p plus 7p, that'll give me 11p. And if I say 3q plus 3q, that'll give me 6q. And minus 5 plus minus 11, that'll give me minus 60. So this didn't help at all. I still have the q here. So adding these two equations won't work, right? So we're not going to add these two equations. Let's try subtracting. If I subtract these two equations, and better yet, let's rewrite them. Let's say equation 2 minus equation 1. I'm going to do this since we have some of the larger numbers in equation 2. So if I rewrite it like this now, and I have 7p plus 3q is equal to negative 11. This is equation 2. Minus equation 1. Seven p minus 4p will give me 3p. 3q minus 3q will actually give me no more q's. And then this is the tricky part, right? We have a minus in between here. So this is not just minus 5, minus 11, minus 5, right? This is actually minus 11 minus 5. Because we have to do minus 11 minus 5. Understand? So let's look at what happened there. We will get 3p minus 11 plus 5. A minus by minus will give me a plus. And that will give me minus 6. So p is equal to minus 6 over 3. We made this linear now by eliminating the q. We have one unknown here. At this point, right, there's one unknown value. Because here, we eliminated q. Now, this is the part that most students have a little trouble with. This is the part where a lot of students have a little trouble with. after we get to this point here, and we're saying that we work out P to be minus 2. This is basically telling us that P is minus 2. It is minus 2. It means that we don't need to use we do not need to write P anymore. We could substitute minus 2 wherever we see P. So, if I take equation 1, in equation 1, which is equation, this equation right here, 4P plus 3Q minus 5. Four P plus 3Q is equal to minus 5. And I say substitute minus 2 for P. It means here I will put a minus 2. But I have to put back everything else. 4 3Q minus 5. This will give me negative 8 when I multiply 4 by minus 5. I'm going to move this negative 8 now. We have a linear equation, so we could go back to what we are accustomed to. So minus 5 plus 8. And 3Q will be equal to plus 3. Then I'm going to find what Q is. So Q would be equal to 1. So my answers is P is equal to negative Q and Q is equal to 1. All right, so here's the solution for that question. Remember, we identifying two values or two coefficients that are exactly the same. That's going to be this little area here. You want to eliminate these. So the options you have is either to add or subtract. If I add, I wouldn't eliminate them because then I'll end up with 10y. If I subtract 5y minus 5y, I'll get 0y. So that's influencing my decision to minus here. The other thing influencing my decision are the numbers. I have a 12, a 5, and a 65 here. I want to kind of work with easier numbers when I subtract. So I'm going to do equation 1 minus equation 2. So it'll be easy for me to simply say 12 take away 9, 65 take away 50. Right? 12 take away 9 will give me 3x, 65 take away 50 will give me 15. I am then moving this 3 across here. So I get 15 divided by 3 to give me 5. Now that I have x is equal to 5, this is the little part where a lot of people get confused. Maybe it's because the way we word it as teachers. So here I want to say, in equation 1, and I'm saying what equation 1 is, 12x plus 5y is equal to 35. Substitute x as 5. So instead of writing x, I am replacing that x with a 5. Yeah? Hope that's clearer. So 12 by 5 would give me 60. And then I can move this 60 over my equal sign. I get 5y is equal to 65 minus 60, which will give me 5y is equal to 5. Then when I move this other 5 here, I'll get 5 divided by 5, which will give me 1. Yeah, everybody okay with that? So our answers is x is equal to 5 and y is equal to 1. Right? Here's another one that I want you to try. Let's do one with the... So before we step it up, I'm keeping them simple for a bit. And then we would look at different signs and stuff like that. So here you're going to do the same thing for me again. Right? I'm going to help you a little bit. We're looking to box up a pair that have the exact same coefficients. So this is what I want to eliminate because I have the same number in front of it. The next question I ask myself is how am I going to eliminate it? Am I going to add or am I going to subtract? If I add, I will not get 0. If I add, I'll get 6x. So that means I need to subtract. So which equation am I going to subtract from which? On top of here, I see I have a 15, I have a 12 underneath here. I have a 4, I have a 2 underneath here. So I would probably go with equation 1 minus equation 2. Can you try this one for me? Take a look at this one. So we identify that we're going to eliminate the x in this question, right? We then looked and we said it would be a situation where we have to subtract, because if I try to add these, I'll get plus 6. If I subtract 3x from 3x, we get 0. So equation 1 minus equation 2, 3x take away 3x will give us 0. There's no more x's here. They're gone. But I want you to pay attention to your signs, because you see, I have a negative sign here or a minus sign here, but I have a plus 2y here. So it's important for us to write it like this so that we can work out our net sign. It's 4y minus 2y. And 4y minus 2y would give us 2y here, right? Right, so we were saying that when we subtract 4y minus 2y, we get 2y. Now, when I move this 2 across here, I'm getting 3 over 2. Now, that's okay, right? I know you all really like to look at fractions, but look at what will happen. If in equation 2, which is 3x plus 2y is equal to 12, I replace this y with 3 over 2. If I have 2, and I multiply that by 3 over 2, we can look at this 2 as 2 over 1. With fractions, these 2 will cancel out, leaving me with 3. So that's how I'm getting 3 here. And then I will move the 3 across the equal sign. Right? Move it across the equal sign to get 12 minus 3, which will give us 9. Then I will move this here. 9 divided by 3 will give us 3. So my answers here will be y is equal to 3 over 2 and x is equal to 3.